Fundamental Theorem of Calculus. Let f be a continuous function defined on the interval ab and differentiable on the open interval ab. Then the function g of x, which we'll define as the integral from a to x of f of t dt, is continuous on the interval ab. It's differentiable on the open interval ab, and indeed, g prime of x is equal to f of x. Part 2 of the Fundamental Theorem of Calculus says if capital F is any antiderivative of little f defined on an interval, closed interval ab, then the integral from a to b of f of x dx is capital F of b minus capital F of a. This antiderivative is guaranteed to exist. As an example, let's find the derivative of the integral from 2 to x of sine of t dt. Fundamental Theorem of Calculus part 1 says that the derivative of an integral from some number a to x of a function, for example, sine t dt, should be equal to that same function evaluated at x, so sine of x. As another example, let's evaluate the area under the curve of x squared plus 1 between -1 and 1. Well, by the second part of the Fundamental Theorem of Calculus, we can take any antiderivative of x squared plus 1, for example, x cubed over 3 plus x, and evaluate at our b and our a, so our 1 and our -1. Evaluating at 1, we get a third plus 1, and then we subtract the same thing with -1 in there, so minus a third minus 1, and we get the answer 8/3. So Fundamental Theorem of Calculus Part 1 helps us take derivatives of integrals. Fundamental Theorem Part 2 tells us how we can compute those areas without having to do Riemann sums. Let's evaluate the integral from 1 to 3 of 1 over x plus e to the x minus 3x squared dx. Now, of course, if we were to do this with Riemann sums, this would be incredibly difficult. However, our second fundamental theorem of calculus makes this super easy to evaluate. First, we simply find ourselves an antiderivative of the function. The antiderivative of 1 over x is log absolute value x. The antiderivative of e to the x is e to the x, and the antiderivative of 3x squared is x cubed. We then just need to evaluate at 3 and 1 and subtract. So we get log 3 minus log 1 plus e cubed minus e to the 1 minus 27 plus 1, which gives us natural log 3 plus e cubed minus e minus 26 as our final answer. Again, far easier than taking a limit as n goes to infinity of an infinite sum. Another example. Your deep ocean oil rig has suffered a catastrophic failure and oil is leaking from the ocean floor wellhead at a rate of V of t equals 0.08 t squared minus 4t plus 60,000 barrels per day, where t is the time in days since the failure. Compute the total volume of oil released during the first 20 days. Well, the total volume is the integral from 0 to 20 of V of t dt. We know that V of t is 0.08 t squared minus 4t plus 60. Finding the antiderivative, we get 0.08 t cubed over 3 minus 2t squared plus 60t evaluated at the endpoints 20 and 0. So we get 0.08 times 20 cubed over 3 minus 2 times 20 squared plus 60 times 20 minus 0, which is approximately 613.3 thousand barrels of oil lost during the first 20 days.